Typically, people refer to it as CCW. That's the latest Allen Bradley software, stands for Connected Component Workbench. So I'm going to open up CCW. There is at least two other versions of ladder logic programming software. Ars Logic 5000, Ars Logic 500. Those are the ones that I remember that I use that are still out in the market. And you actually are maintaining or refurbishing or retrofitting equipment, you might find a lot of the equipment that's still powered by that old software. So this connected component workbench is for the newest hardware that they have. But again, companies cannot just simply swap machines, right? They gotta get the RIO, return on their investment. And so they're gonna probably have some, older systems. And so in that regard, you're gonna have to go back and kind of study a little bit the older software, which is not much different than this one. Okay, you're gonna have at least 3 resources to move on with the software programming. One is gonna be the recorded Zoom meetings that I'm gonna continue to record them. You can always go back and review those. 2, there is training videos right here, right on once you open the software, it'll link you to the training videos that Rockwell has put out. It's almost like they did those on triple speed because they're fast videos. So you have that resource. And then the other one is I'm going to be uploading the tutorials in PDF documents. So you can just kind of follow through if you want to do that. So the method we're going to be using is basically you're going to do the tutorials and I'll help you do those tutorials. And then after the tutorial, you're going to have an assignment, a project you're going to work on based on the tutorial and a few add-ons. So you have those resources at your disposal. You're going to go back and start. So I'm going to show you how you start a new project here. So you can actually do file like any Windows-based software and do new, or you can just do new project in here. I have no hardware connected to the computer, right? The boxes are up there. But I'm going to use the simulator for this demo. Okay, so I'm going to call this EET 2760 demo 1. That's going to be my project. Okay, and once the project is started, so the project is one large container or folder where you're going to add on whatever it is that you want to have on that project. A project typically will require minimally a controller, right, that you're going to use for the project. But there's at least 5 other things you can add onto a project. It used to be that you had multiple software pieces to do this stuff. And so this is the neat part of this CCW, that they've integrated everything into a single software. So you'll have to pull various pieces of software, at least 2 or 3, to do this integration. So they're making this integration a little easier. And so you have controllers, right, that you can select from. And this is the newest family of controllers of Allen Bradley. They're called micro 800s. Okay, so we have A10, A20, A30, 50, 70, various devices. And then you have drives, all right, which is usually referring to a frequency variable drive. You guys heard BFDs? So BFD is another brain that has been added to improve the efficiency of how a machine runs, right? And you're nodding your head. I'm sure you probably have seen those, right? Mm-hmm. BFD stands for variable frequency drive. And what it is every time you have motors running at full speed, you're probably wasting energy and wasting life of the motor, right? And so let's say you have a production line with conveyors, and for some reason there's a bottleneck or something, and there's conveyors that are empty. You don't need to be running those conveyors, right? And so BFDs will give you that ability to just slow down that conveyor, right? And when they sense the load, they'll speed up again, and VFDs are able to do that. Variable frequency drives. So that can be integrated to here. In addition to the controller, all right, you can have also other soft starters, motor controls. So there is a industrial motor starter that it's typically used to run motors. And nowadays they have soft starters, other forms of that giant industrial control that you can also find here. There is safety relays or features you can add onto the project. Safety is kind of a must-have, virtue or parameter or spec on a project. So that anything happens while the system is operating, you got some form of a safety device to shut that down automatically. And then you got graphic terminals. That's where you build your HMIs, right? And we have actually here a small 4-inch HMI screen that you can add. So again, this is where you integrate everything. We're not going to be using all of that, maybe 2 or 3 of those, because we're concentrating on the controller itself. But we'll do a few things, hopefully at some point, to be able to add. Or how do you automate what you're doing now, and how do you add a sub screen, something like that. So I am going to select a controller here. And for this particular demo, because I want to give you a feel of the real thing, I'm going to shoot the 2080 LC5048 QWB sim. So that is actually a simulation, the simulation firmware that we have available. That way I don't have to worry about connecting the hardware at this moment, right? So Micro 50, and that's the sim that I'm selecting. It tells me here what's contained in it. Like it has 5 plug-in slots with 4 expansion IOs. It's got 28 input channels, 20 output channels. It can handle AC and DC signals. And then the output signal can be sent out to a relay or some sort of a similar device. And then the communication protocol, CIP, so that you can communicate with other things. So I'm going to just select that. Okay. And I'm going to stick with that. That's all I want to do. So add to project. So I've selected the controller we're going to be using, right, for the project. And based on where you think you can deploy, you're going to select that. Now, that controller can be changed once we got the project and you said, hey, I got another controller here, 830 or 820, which is not the original. You can change that controller. As a matter of fact, we can do that right here. If you just right click, you see that change controller. I can change the controller. And you shouldn't be able to lose anything in there. So that's the selection of your controller. And it gives you an image of the controller itself. All right, what the controller looks like. And it's got at least 6 slots that you can expand on, right? Each one of these is a slot. You can add on modules, DC, AC, discrete analog modules. We're not going to worry about those at this moment, but at some point I'll show you how you add those modules. The controller itself already got, like we read there, 28 inputs and 20 outputs, which are these terminals right here. This on top are the input terminals. These down here are the output terminals. And then there's some LEDs that will indicate what's going on there. Now, one other thing you want to do here at some point is these devices now have a way to be identified within a network, right? How do we identify a computer within a network? How do we do that? Yeah, so you need an IP address, right? That is very unique. And we got 2 kinds of addresses, actually. We got a hard address, and we got an IP address. And with this device, this is similar. So you're gonna head to general, and it's going to tell you a little bit about, the name. You can add a description here if you want. It tells you about the memory allocation, what memory you have. You can set up the diagnostic part, whether you want to clear defaults or things like that. This one is the part that is important, Ethernet, because this is where you're going to give this thing an IP address, right? So that if you have to communicate this on a network or with other devices such as the drive or the panel view, you'll have a specific name for those devices. Okay, I think this simulator does this automatically. We're going to give it a shot. So, yeah, because you actually have the same ability on a computer network. You can actually use DHCP to automatically allocate an IP address, or you can do that manually. So I think this guy can do it both ways also. So that's an important aspect, setting up the IP address. All right, let's just see. So the other part that you need to set up here is the communications setup. We actually have a one-line network as we're doing this, because typically what I'm showing you here will be a hardware, right? And in order for the hardware to communicate, both the programming device, in this case, my laptop, and the controller will have an IP address, right? And they'll be able to talk back and forth via that IP address. And so we need to set up a communication system here. So we're going to go to communication. Even though this simulator is within my computer, it's almost like a virtual extension of my computer, right? Nowadays, you actually can create virtual networks because you can create virtual machines within one machine. And so if we go to communication drives, and so sometimes this part can be a pain in the neck. Just setting up the communication to communicate with a piece of hardware. So typically what you do is to set up the communication. And again, I think the simulator picks up this automatically. It's already running though. See that? It's already running. But if you were to do that, you're gonna go available drivers, right? And then you're gonna choose either an Ethernet device or Ethernet IP driver. One of those two, which is the third and fourth options, is what you're gonna need, right? And so one of those two options is necessary. I'm going to, so if I do configure here, you notice that there's already an IP address, right? So that's the IP address that the system automatically allocates, 192.168.1.13. And so we already have that. Okay, let's see what happens. And the next thing, I want to verify that that communication is actually taking place. The way to do that, I can go to this little icon in here under the project organizer. And hopefully it's going to open. And it opens the connection browser. And I can expand here. And I have something I don't particularly care for, which is a unrecognized device. Okay, so that's a little problem, right? It's got the IP address, but it says I don't recognize the device. Okay, that could be due to a couple of things. We're going to try to fix that. But this should be clear, and it should show somehow data that correspond to the simulator. Okay, so let's see if we can fix this. All right, I'm going to cancel that. So what I'm going to do next is equivalent to you saying, I want to communicate with this hardware, but you have the hardware turned off. And so there's no communication. And that's what we have here. So since I selected the simulator, but I haven't turned on the simulator. Okay, this is just the face of the controller. So I need to come here, and there's a couple of spots where the simulator is. Device, connect, build, debug. There you go, tools. So under tools, you can find the simulator right here. Micro had the simulator. That's one way you can pull it up. There's another icon in here. So let me see. I don't see the other icon for whatever reason. Do you guys see an icon for simulator? Yeah, it's probably hidden somewhere. View. But there usually appears an icon on somewhere in here. And I'm not seeing it myself. Okay, I'm not seeing the icon. But anyhow, it's under tools. We're gonna run the simulator. This is equivalent to me physically connecting the hardware and running that hardware. So there is the simulator, and of course is off, right? Now the interesting part here is that now we have another IP address. You see that? Okay, there's another IP address. So, and there's even a software loopback interface. So I'm going to maintain it there. Okay, this is usually a source of problems when you're actually dealing with a real controller, right? This could give you a lot of trouble because you're basically setting up a little network in here. And so anyhow, I am going to power this on. Okay, so that's equivalent to me, you know, flipping the light, the power switch on the controller. All right, and I have no errors, which is good. All right, it's in remote mode. Not we talked about the operation modes of controllers, right? So there's the run mode, and it gives you that little warning. It says the simulator operates for 10 minutes in run mode. Okay, and then it'll be switched to program mode. That's okay. We're using a free piece of software, right? And I say, do not show that again. I already know that. You can also put it in program mode. And of course, just like you would have a machine operation you're trying to repair, you're gonna have to stop that machine right before you can send a new program over. So when we're uploading or downloading programs, we need to have this either in remote mode or program mode, and then switch that over to run mode when we wanna run it, right? So anyhow, there is the controller running, and I am going to go back to the communication network, and hopefully we should be able to see, and it says unrecognized device. Okay, so I'm going to do another thing here, an additional. I'm going to use this IP address 192.168.13 to label it on the part that I have control over, which is this part right here. Okay, we're gonna put that IP address. Okay, and it won't let me. Maybe I have to turn this guy off. Okay, I'm gonna exit the controller. And there you go. So it's not letting me do that. That's a bugger. It's not even connected, right? Not connected. So these are the things that you come across. I mean, various kinds of, you know, connection pieces behind the scenes. Okay. I am going to try to, if I can download this empty project. I mean, you do various things like that, right? I'm actually attempting to establish communication with the controller. And here we have that unrecognized controller. I'm gonna see if it picks it up. And if it downloads the unrecognized controller. Or we'll have some error. So this part you don't have to do every day, right? Because once you set it up, I'm just going to show you the setup process, which can be painful. The easiest thing for me to show you here will be to just open up a project I'll be working on, right? So it says connection fail, and the connection fail because we don't have the controller in line. And so I'm gonna go and bring up the controller, Control Alt T. Yeah, the former professor in this department that taught this class told me last year he spent about half of the semester just to get this going, right? And it happened to be that there was a firmware update that he did that he wasn't required to do. So students were just trying to get this connection going. Okay, so let's turn this on. Okay, and I have a couple of options in here. I might have to match up this IP address with the IP address that is already set on the system or something else. So we're just experiment. I'm gonna download one more time. Because the funny part is not letting me manually write the IP address. Okay. I don't know what Google is doing here, so I'm gonna tell Google. I think there's an attempt to download, so we'll just have to see. Again, once you have this set up, you basically just open up the project and keep on adding. It shouldn't be a problem. And I already have it for other projects that I may just simply open and go from there. Okay, connection fail. So yeah, and the connection failed because we have here a unrecognized device. So I am going to do what I told I'm gonna do, which is based on the assign IP address. I'm gonna write that down. I'm gonna try to reset the drivers for that thing. So 134, 250, 128, 76. Okay, so I am going to go back to communications, configure, and I'm gonna add another device. Yeah. And this is the device, right, that we're looking for. Okay, so I think I captured the device we wanted. Now we have two. You see it? So you have to do one of two things, right? If the system DHCP is an IP address, you have to match that on your driver. The other thing would have been to manually assign an IP address, which didn't let us do that, and then do the same. So these IP addresses have to match. Okay, so we should be good. Okay, for this particular project, as a matter of fact, I may have to remove the other driver, but I don't have to. So this setup usually it's the beginning of your project, and it's going to take as much time as it's taking us or more to get those bugs out and get that communication set up. So it's going through the routine process. Okay, I think we're good. So you can see here also another little light that it says it's in program mode. So if we bring the controller, yeah, upload successful. You see that right there? So upload successful. So we are all set, right, with the communication. It takes a little while. And so, but the key here is there an IP address assigned by the computer? If there is one, then I'm gonna have to go back and add another driver to match that IP address. Okay, so we did that. Okay, so you're ready to start your project. That's project setup. In the project folder, assigning the resources you're gonna use for the project. And in this case, knowing that our simulator is our resource, main resource, we have to match those IP addresses. At some point, if we plug in one of those boxes, then we're going to have to do this again, right? Assign an IP address to the controller itself. All right, I'm going to minimize this guy right here, and I'm going to show you how you actually start a project. So we got a few little things here on the under the controller itself. And actually, I'm blown away that there is actually a project already here. You see that motor circuit right there? There's some. So if you wanted to add a new project, you're gonna right click, right click, and then you're gonna add. Uh, and of course, at the moment, it's not gonna let us add because we're in line with the controller. Okay, so we need to disconnect from the controller. But this is we're gonna add a project, and it gives you three choices. You can add a project that's going to be designed in structured text, ladder diagram, or function block diagrams. Okay, so those are the options. I'm going to disconnect here. So because we already got communication, okay, we have no issue. I'm going to open up and see what I got here. There's a motor circuit project. I don't know why that came out because this is a brand new project. And I don't know how this guy got in. So, hey, here we got a little ladder perm, right? And so you recognize the inputs on this one, right? We got a stop button, that's the tag. We got a start button, that's the tag. We got an output motor, that's the tag. But in addition to the tag, there's the addresses of those commands or instructions, right? In this case, is digital output 0, DO 00. This is digital input 11, and this is digital input 10, right? This one right here, if you see, is a repeat, right? That actually is the same address of the output, which means that's the retention. We also have right here a digital input 0, which is a photo sensor for this particular project. And then we have a proximity sensor in here. Okay, so let's see if we can run this little demo project, and then I'll help you. So this is essentially what you guys are doing with hardware, right? This is pretty much what you're doing, except for the additions of the photo sensor and the proximity. But you're doing that part via hardware using relays. So now we can translate that into a software program. All right, so let's go ahead and download, if we could, this project. I go to the controller, that's not a way to do it. I'm going to download it to the simulator. It says build successful. All right, and download with project values, you can do that or just download. Download with project values, if anything is enabled or disabled, it's gonna write it down that way. We're just downloading the project. Download 1 successful, fail 0, up to date, 0 skip, 0 errors. It takes a couple of minutes to download those projects. All right. And this is your report of your download right here. So it looks like you download correctly. I'm going to bring up the simulator. Let's see if I can move it around here. You guys can see it. And I'm going to switch the controller to run mode. Okay. And this stop button actually should be a normally closed one, right? All stop buttons are normally closed. So digital input 10 should be closed, right? Because the idea is when I want to stop the circuit, I'm going to break that path, right? So that should be a close contact, or else I'm going to force it to be closed as I did. And then digital input 11 is my start. Press release, and the project's running, right? Indicated by the red flow line of electrons. Okay, so that's one way to get that running. I'm going to stop it. Put the stop button back in its place. Photo sensor comes on, right? Also runs the output. Photo sensor goes off. The system's still running. I'm going to stop it. Okay. Proximity sensor comes on. Digital input 01. Energizes. Proximity sensor goes off, but stays energized because we got a seal right on the circuit.